Hi, this is a video for the checkpoint transformations of exponential functions. So first we have an example where it gives us f of x equals 3 to the power of x minus 2, and then we can see that the pink is the transformation. So we know it's been reflected, it's flipped over the y-axis. It's also a little bit steeper, so we've got two things that it's doing. It is flipped over the y-axis, and that's where this negative comes from. And then the fact that it's steeper is where the 4 comes from. So it's being stretched vertically. And it can write that two ways. It can either put that in the exponent, or it can say f of negative 4 times the x. So you have two answers on the question like that. Okay, then we've got f of x equals 3 to the power of x, g of x equals 3 to the x minus 4. So the change is the minus 4, and it's on with the x value in the exponent. So anything with the x value is going to be opposite. So when it says minus 4, it's really moving in a positive direction. Because it's the x value, the positive direction is to the right, so it would be moved right 4. Okay, and you can always plug these into Desmos, and you can see how the change goes. So let's do that. So this is Desmos, desmos.com. You don't have to put f of x equals, you can just put the equation. So we had 3, and then this little a with the b above it is how you get the exponents. So 3 to the power of x, and then you can tap the next line, you can put any equations you want in here. So we're going to do 3 to the power of x minus 4. Oh, but it didn't stay in the... So you might have to put that in parentheses so it stays all in the exponent. And you can see that it's the same exact line, it's the same function, it's just been moved to the right 4. Okay, same thing goes here. We've got f of x equals 4 times 2 to the power of x minus 5 plus 6, and then f of x plus 3. Again, we've got this x value that's being changed, so that's going to be either a left or a right. And anytime you're moving the x, especially when it's in parentheses, it's going to be the opposite. So it's actually moving left 3. Okay, we've got 4 times 2 to the power of x minus 3, and then 4 times 2 to the power of x plus 5. So we were at negative 3, and now we're at positive 5. So these are the values at the end, or the k values. They're not associated with the x. So this number at the end is either moving up and down. It's talking about your y values. So if you start at negative 3 and then go up to positive 5, that is 8 up, 8 positive up. F of x equals 4 to the power of x, and then g of x equals 3 times 4 to the power of x. So we've got this number outside in front of our function that was added. The number is greater than 1, so it's going to be a stretch vertically, and by a factor of 3. So everything's just going to get taller. F of x equals 4 to the power of x, and f of x equals negative power of x. Okay, so the x values are made the opposite. And so if we're changing the x values to opposites, so everything that's positive is negative, negative is positive, that is going to reflect over the y-axis. So it kind of just flips like that. Again, something you can put into Desmos. We can try this one really quick. 4 to the power of x, 4 negative. So you can just delete these. So I'm going to go 4 to the power of x and 4 to the power of negative x. And you can see it's just reflected over that y-axis. And then we've got f of x equals 4 to the power of x plus 3, and then 4 to the power of negative x plus 3. Again, we know that what that's going to look like. It's going to reflect over the y-axis. Nothing else changes. Doesn't move up, down, left, right. It's not stretched or compressed. It's literally just going the other direction. Okay, f of x equals 3 to the power of x plus 1, and then now we've got this half out front. So again, nothing else is going to change other than everything is going to be cut in half. So you can see that it's just lower, but that's because the distance from the x-axis is cut in half. And the easiest way is if you're looking at points, let's say these 2 points were on our graph. We would have 4, 8, and now we have 4, 4, because everything was cut in half vertically. Okay, so notice the x value is not cut in half. It's not cut in half left to right. It's just cut in half up and down, so just the y value. Okay, the a value comes from the points, and we can see that in this last question. Because there's a number out front that changes the y values of the points on the graph. So 8 became 4 because it was cut in half. So the same thing goes here to figure out your a value. If you look at the points on the graph, you can see, well, it was at 7 because f of x is our original. And now we're at 21. So 21 divided by 7 is 3. And so that's our a value. Everything got multiplied by 3. It would be 3 times further from the y-axis, sorry, x-axis. Then we have dilations. Okay, so same thing. What we've been working with are dilations where the a value is changed. So we see f of x was at 3. We ended at 18. So that's times 6. So we have 6 times whatever the equation is. And that wraps up our checkpoint. Good luck on your assessment.